In this video, we are going to be doing example 5.4 on page 124 of the AP Physics textbook, a traffic light at rest. So here is the problem. A traffic light weighing 122 newtons hangs from a cable tied to two other cables fastened to a support, as shown in the figure. The upper cables make angles of 37 degrees and 53 degrees with the horizontal. These upper cables are not as strong as the vertical cable and will break if the tension in them exceeds 100 newtons. Will the traffic light remain hanging in this situation, or will one of the cables break? The way you always want to start these types of problems is to draw a free body diagram. Remember that free body diagrams, we want them to be as simple as possible. So this little dot here is going to represent my traffic light, and this will be the horizontal. This is T1, and this is T2, and this is T3. Now, what is the question actually asking? Well, it's saying that in this cable and this cable, they will break if the tension in them exceeds 100 newtons. So basically, we want to figure out what T2 and T1 actually are. And we know that T3 is a stronger cable. Let's label our angles here as well. Okay. One thing we can assume is that the x components of these two tensions have to be equal. So in other words, these two pink lines are equal because the traffic light is not moving from side to side. And then another thing, we need to find out if these two can actually hold the traffic light up. So we know that the y component of T1 plus the y component of T2, in order for them not to break, they have to be equal to T3. We also know that T3 is going to be equal to the weight of the traffic light. So right off the bat, we know that T3 is equal to 122 newtons. And as I was just saying, T1x equals T2x. So that's because the traffic light isn't going in on either of these sides. And we know that T1, the x component of T1 is going to be T1 times the cosine of 37 degrees. And the x component of T2 is going to be T2 times the cosine of 53 degrees. It's always better to put in numbers as soon as you can. So let's find the cosine of 37. And it is 0.7986. And the cosine of 53 is 0.6018. The reason it's better to find numbers as soon as you can is because that means you will make fewer algebra mistakes. All right, we also know that T1y plus T2y has to equal 122 in order for the traffic light to not fall down. And we can translate that to the y component of T1 is going to be equal to T1 times the sine of 37 degrees plus And then T2y will be T2 times the sine of 53 degrees, and that is all equal to 122. Again, you always want to put in numbers so you make fewer algebra mistakes. So the sine of 37 degrees is equal to 0.6018. And the sine of 53 degrees is equal to 0.7986. Now these numbers should be looking familiar, and the reason is 37 and 53 degrees are complementary angles, so the sine of one complementary angle is equal to the cosine of its complementary angle. Anyway, just some reminders of trig. So we have two unknowns, and we have two equations. So we need to brush up on our algebra and use system of equations. What I am going to do is I'm going to solve this equation for T1 and then plug it back into this equation. If I solve this equation for T1, you get that T1 is equal to 0.7536 T2. Again, I'm going to plug this into here. Once you plug that in, you'll get 0.6018 times 0.7536 T2 plus 0.7986 T2 equals 122. Let's multiply these together, and you will get 0.4535 T2 plus 0.7986 T2 equals 122. Okay, combine like terms. Now divide both sides by 1.252, and you get that T2 is equal to 97.43, and this is a force, so the units are newtons. Then, since we know that T1 is equal to this, we can just plug in our 97.43 into here. So T1 equals 0.7536 times T2, so 97.43, and you get 73.43 newtons. So we found the two tensions in the two cables, and remember the original question asks, will the traffic light remain hanging in this situation, or will one of the cables break? Remember the max tension is equal to 100 newtons. Are either of these above 100 newtons? No. So the traffic light will remain hanging. In other words, the traffic light is in equilibrium.